Hey everybody, have a pair of solar lights. Well, really one solar light, but wanted to compare it to another one. Today I went to Goodwill and ran across this thing. An SMC Lighting brand quick charger light, solar cordless outdoor light. Has a lot of good selling points. It has quick charging solar panel, save charging time. It's made by SMC. Now I don't know if that's the same company as the SMC that makes, networking stuff, but it's Hong Kong, so maybe. There's the side. Oh, some glare on that. It's all you need. This light right here. It's simple to attach. Oh, that's the same thing. But you can see it has an anti-theft base. And it really does. It comes with all sorts of mounting hardware. It's got some steel brackets. And then it has the mounting poles. And I think this all just kind of snaps together with pins. I don't think there's any screws. Or if there are, they're not included. I'm pretty sure it was installed somewhere. It looks like somebody else had it apart. Here's the base. But aside from that, there is... Oh, wait, there it is. It's hidden under a piece of cardboard. Okay, there's the hardware. Yeah, so, let's see. They give you a couple screws and some rivets. Pins, I guess. So, yeah, it's quite a bit different than the normal garden walkway light that you see today. More ways than one. The light bulb in this one, oh, wrong side, there we go, is an incandescent. See? Let's see if we can get there. There's a filament in there. See that? There's that filament. It's about the size of an LED too. It's kind of funny that, oops, didn't want to do that yet. It's kind of funny that that little LED there puts out much more light than this incandescent right here, especially when you compare the size. You need all that, all those cells, instead of just those. So let's see, we could fit one. Well, if we were just generous, let's say this equals, what is that? 2, 3 sets? Yeah, that's crazy. 1, 2, 3. So there's like at least 6 of these in comparison to this. I'm not quite sure how many volts that puts out, but we'll open it up and measure. As we'll compare. This one is charged. You can see it's one of those bright white ones. So that'll just throw off way more light. And then this one has that reflector in it right there. So let's put this off to the side. And let's start opening this one up. You can see it's got a good construction. Nice injection molded plastic. It's feels well made. Has threaded inserts in the plastic to hook those brackets onto. I guess that's this bracket right here. Yeah, that lines up, or I guess it would have to be that way, because you're supposed to mount this so it's, relatively vertical. Let's see, how vertical is that? That's pretty vertical, although you'd want to have a little bit of an angle to it so that the water runs off. But that would make sense for this. That way this is throwing its throwing its light out that way, because it is a walkway light. And that's plastic. That's not glass. That's good. You probably could put glass in there, depending on how that's... Doesn't quite feel like it's glued in. Let's see. Let's start with this panel. My guess is it has a lead acid battery or nickel, nickel cadmium, nickel metal hydride, but it's kind of heavy, this thing. It weighs, I don't know, it's heavy for its size, I should say. There's something in there, so I say lead acid. Especially since this looks like it's, I don't know, early 90s, like very early 90s maybe? Maybe 80s? I don't know. I don't recall seeing these, but, never really kept my eyes open for them when I was younger. So let's see. That should, yeah, there we go, it's loose. Yep. That looks like a lead acid battery to me. It feels like it too, it's heavy. Let's see, let's get those wires off. And, okay. So let's get these off and see what kind of battery's in there. We'll take this side off. Alright, so loosen that a little bit. There's little pins that kind of lock it so you can't just spin it. So loosen that side just a little bit. There we go. Ah, yep. Oh, it all just came off. Alright, whatever. Alright, so there you go. It has an LCR 6V 1.3P, 1.3 amp hour at 6 volt, 20 hours. Wow. That's pretty good. Can sort of see the inside. Now, sometimes you can fix these. They're maintenance free, quote unquote. But usually they have some kind of vent where you can replace the electrolyte. This one's probably long shot, but just to humor us, let's pull that off. And there's the cover. Yep, that's a piece of rubber. And then there's the plates in there. Now this is probably a total waste of time, but I have some water and it's through reverse osmosis filter. Alright, so this is a total gamble. I refilled, or I'm refilling the cells with water. Looks like there's enough. Put about 2 tablespoons in, and I can see it right above the plates on here. And this one's a little low, but what the hell? A little bit more. Not sure how old this is. There's no obvious date codes that I can find. I would think there would be, being that it's a battery, but who knows. See, really nothing there. And there's nothing on the bottom that I can see, but I can't flip it over at the moment. So let's just it's just on the top. It's like a bubble. A little more. There you go. That looks pretty good. So now what I'm doing is I'm tilting it and I'm looking for them to start to overflow at the same time. Now I know they're all the same fill level. There's enough room for some expansion, which is good. So let's cram the cover back on. That foam in there. We'll slide that plate in and there we go, and we'll just do one piece of tape. Alright. So I doubt we're going to see any voltage yet, but let's see. Negative voltage. I think it's going to need a little bit of a charge. I'm going to go set this on the battery charger and see what happens, and then we'll get back to the light. And now we're back to the light. I have the battery hooked up to a bench supply, hitting it with about a little over 8 volts, trying to see if I can get the cells to jump start. It's drawing about 1 milliamp. It started out about half a milliamp, and it's slowly creeping up, so it's starting to take some voltage and some current. So I'm going to keep an eye on it and see if it starts actually doing anything. Maybe we can rejuvenate it. I doubt it, but stranger things have happened. It is a Panasonic battery, so you never know. So anyway, let's get back to this. You can see this is where the battery connects. Let's actually fire this up. That would be fun. And to do that, we are going to use a portable power supply that runs off my drill battery. I'm sure you've seen these. I forget the model number. Does it have it in here? DS something or other. I forget. But anyway, let's get this to the right voltage. Battery 6 volts. Let's go 6 volt, and what did it say it was? 1.3 amps. So we're at 1.6. We'll take it down to 1.3. There we go. And let me get the alligator clips. So this is going to act like the battery. The solar panel will be feeding it, but since it's pointing down at the bench, I'm really not that worried about it. It'll black it out. Now let's turn on the battery. There we go. And it's running 6 volts at 50 milliamps, drawing about 0.3 watts. Hopefully you can see that. There we go. So that's what it's drawing while it's running. That light is really dark. In fact, let me just turn off all the overhead lights. There we go. Now all the overhead lights are off. You can really see how bright that is. I mean, it works. I'm sure for whatever year this was, it was pretty good. But compared to now, there you go. There, we'll point that one at the lens so you can get it, and then point that one, and I think it's pretty obvious which one's brighter. And this one's running off 1.2 volts nickel metal hydride, and that would be a 6 volt lead acid battery. And the light's kind of neat. I like that warm white, but we could put a warm white LED in there as well. So yeah, you can really really see the difference. Alright, let me turn the overhead lights back on and we'll start digging into this some more. Yeah, this is a handy little power supply. Runs off of DeWalt battery. I made the battery bracket, so it just slides in, locks in, and it comes on as soon as you plug it in. You can use a barrel connector too if you wanted to plug something right into it. And this is just a normal box. There's nothing special going on in here. So, but it's handy because it's portable. I want to make another one so I can plug 2 batteries in and be able to run from 24 volts down. I do wish these were boost converters as well. That would be cool instead of just buck converters. If there's a model out there like this that does that, let me know, because I would really like to have that. Alright, so now let's take these 6 screws out around the side. Now I sort of think somebody else was in here, kind of, or maybe some of the screws were moved. There's 2 screws, one in particular that looks like somebody just had the wrong size screwdriver in and just went to town on it, which is kind of strange being that it's plastic. Like it shouldn't matter, it should be easy to stay tight. So there's a screw that's all chewed up, and there's one that's not quite as bad but similar. So it looked like somebody had the wrong size driver and just, I don't know, sat there and spun it. Oh, let's get the tape off. Alright. So there's the solar panel on the inside. This thing's filthy. It is plastic. Oh, and there's a gasket. Huh. There's like a rubber silicone gasket there of some sort. Urethane maybe. But yeah, oh, that's cool. It's good to know. Then there's the inside. Put that off to the side. There's all the solar cells. These are, oh crud, I forget how many volts they are a piece. Let me check. So let's see. So this is charging at 1, 2, 3, 4, 5, 6, 7, 8, 9. 4.5, 1, 2, 3, yeah, same, 9. So 4.5, 4.5, 9 volts. Yeah, that would make sense for charging a lead acid battery, although there might be some voltage drop depending on charge circuit. This is definitely hand wired. Look at those. You can see that's definitely hand wired. You know, maybe I can turn this into lithium. I could parallel these up, get more current and run it at 4.5 volts. I mean, that would be overkill almost. Maybe I should really parallel them up and that wouldn't work. Not an even amount unless I take 2 off. There's some type of adhesive holding them. I don't want to break it. But that's kind of neat. Somebody took single cells, probably double-sided tape, stuck them to there and soldered it all together. Alright. Those have to go in their spot. I do keep the screws organized because I want to use this for a project where I put something brighter, you know, maybe a big cob or something in there. Alright, so this comes out. There's the inside. We are in. There's the guts. So it's just 2 wires, so you can see the back now. You get a better idea of how that's wired. You can see the back of each of the cells. They must put them in and then wire them, maybe. It's hard to say. Let's see, I'm going to leave that connected. I'm going to leave all this connected if I can. Pull the battery wires through. I don't know how much of the circuit I'm going to reuse, but we'll see. The light bulb just pops out. There's the light bulb. Oh, there we go. There's the light bulb right there. It's a little incandescent guy. Oh, it's in a socket too. Had to try. There. There it is. Just a little single filament. No markings on it, but not sure. Oh, I should measure the voltage going to the light bulb. Let's hook this back up so we can do that. Get my other meter. Let's see. I get that, and then power supply again. Alright. We get these guys ready. Okay, we're good there. And jumpers. Alright, negative, positive. Just want to make sure they're not going to hit. Plug them in. There we go. Make sure it works first. And what did I do with that? Well, I'll just put my thumb over it, can I? Nothing. What did I not do? That's on, that's on. Oh, it's off. Oh, that'll do it. Power does make it go better. I need a new piece of tape though. But no, I don't. I found it. Oops. What am I not doing? Oh, wow. Very sensitive. Very sensitive. Okay. I need to figure that out. Maybe I can... There we go. Okay, so now it's on. And this says it's drawing, what's that, 50 milliamps. So there can't be a whole lot of voltage out there. That filament is definitely not running to its full brightness. Now the question is, can we check it? Should probably do it at the board. Can I do that and still film? Let's see. I go in here, touch that one. Hey, there we go. Hopefully you could see that. Let's try it this way maybe. Alright, so 2.5 volts going to the bulb. So really I could just plug an LED into that if I wanted to. Okay, so I did find a warm white LED to put in there, but the source voltage I believe is 6 volts. Let's see, make sure that's not being washed out. That's on. Get a little, just so you can tell that the just so the sensor, light sensor, doesn't get tripped, or does get tripped. Let's see if this will work better. Because that plate keeps moving around. That's making me nervous. So let's see here. 6 volts. Oh, I'm blocking it, of course. So yeah, 6 volt source voltage. These drop about 3 volts. So to get about 15 milliamps, have a 200 ohm resistor. And this has a socket, but I was thinking of putting the resistor underneath, but instead I think what I'm going to do, just mark this side so I know what side's negative. Oh, just put it down here. Yeah, positive. I think what I'm going to do is cut the leg on the LED and hook the resistor right. Maybe now you can kind of see it. I was trying to get it set up so you could actually see what I was doing. So I will make that resistor lead a tiny bit shorter. So I want it to sort of tap against the bottom of the LED. First, let's get a little fresh solder on here. Yeah, there we go. Just a little bit. And same thing on the resistor. There we go. Nice clean joint. Then we will just trim it even. And now it can plug right in to the socket. It should just... Yep. Alright. Gonna move this. Let's see if it comes on. Hey, look at that. See, that's much brighter even out of the reflector. That's still really bright. I can only imagine how long that'll run. Let's see. So it is drawing 16 milliamps at 0.09 watt. So that should run for quite a while, especially when you factor in the rest of the circuitry. It's still pretty good. Move that out of the way. Alright, so let's turn that off. We'll get this out of the way, and let's look at the charge controller and the photocell circuit, especially now that it's LED. Alright, I'll turn this back on. Now to take the controller out, oops, there we go. There's just 2 screws going into some standoffs. That's my tape to fool that into thinking it's nighttime. Put those there, put light bulb here. Alright, so now the board should just kind of, just have to, let's see, yep, that's the only screw. There we go. Just have to kind of wiggle it out. So there's the inside of the case. It has metal reflector, just kind of tabbed in with the plastic being melted, some kind of glue here. So, you know, it's a decent mold. So anyway, let's look at the fun part. Here's the controller. That's very basic. We have a transistor, definitely not a MOSFET, a little old for that. The board makes me think it's, oh, actually, hold on. We have a part right here, looks like it's a comparator, 2904, and it says 8301, so probably first week of 83 that chip was made. So that makes this board, and I agree with the way the layout is, this is probably early to mid 80s. You know, 83, 85, somewhere around there. It has a barrel connector here that's not populated. See? There's the positive, I think. Yeah. And then, wait a minute. I'll bet that's, yeah, right here. See, that would be drilled out. I wonder. I happen to have a drill bit that fits almost exactly. Let's there we go. And then I just need to put a barrel connector. A little bit of that plastic out. It's have to solder a barrel connector. There we go. Into here. I'm pretty sure I have some of these around. Just a normal one. And then I can. Let's see. Is that going to? Oh yeah. Then I can just charge it through here if I want to. So I'm thinking about if that lead acid battery doesn't work out, I'm thinking about putting, you know, a different kind of battery in here. But I kind of want to use the lead acid, so I may just buy a new one of those, worst case, because that'll run this LED. We'll do an experiment maybe and see how long the LED runs for. So now that this is out, get to the next part of this, which is where I wanted to compare to a modern one. I already have the screws out to make this a little easier. You can see this will represent the battery because that's about the size, and this is the battery in this one. So what's going on here is it's different. It's different, but it's not I guess it's really not as different. This one's a little easier to understand, I guess, being that this one, well, this one's easier to understand because they're using a chip. There's just that one IC that does the control of the system and the charge controller for the battery. It's all kind of one thing, which I should have removed the screw so you can see it. I'm talking about it, not showing it. There we are. Okay, so that, as you know, there's tons of videos on these out there. That 4-pin chip does all the work with that inductor. That's how it boosts the voltage to drive the LED. It's also how it knows when to turn the LED on. When the voltage drops from the solar cell enough, it turns the LED on. And while the voltage is up high enough, it's then also charging the battery. Now this one, let's see, the solar and the battery connect next to each other. So it's plus minus, minus plus, so they're sharing negative, which makes sense. And then battery goes in here. Yeah, battery goes in here, goes through the switch. Feeds through that, that's a big resistor. Let's see, 1 meg, yellow, 5 zeros. So that's a big 1 meg probably, or yeah. All right. No, it's driving me nuts. One zero. 1, 2, 3, 4, 5. 100,000 of them. Okay. Then, see now I gotta. I should know this off the top of my head, and that's bothering me. Oh, come on. 100K. Okay, I was right. 100,000. There's a diode here, which to me looks like an LED. I don't know if that's, yeah, that's not enough. Oh yeah, that's an LED. That's an old LED right there. I have it marked as a diode. Maybe that says when it's charging. I see if I can get the panel to put some power through. Not really. I don't have enough light sitting in here to really drive it. So we'll just do that and keep looking at it. So that this chip is doing all the work of when to turn the light on and off. It's comparing the voltage from the photocell, I'm pretty sure. Let's see, we have a diode going to one side of the photocell. The other side goes to, yeah, there's a lead going in. And then I'm pretty sure this this pot here is for adjusting the threshold, because it is connected. Is it connected? It's part of this network right here, so I imagine it is. And then this transistor is what's turning the this is what's controlling the LED or the light. The base is coming off of that resistor, which is jumping across and going, yeah. So that's going to pin 1 of this 2904. So that makes sense. That's the one of the outputs. I think it's dual output. So I think it's, let's see. Yeah, that would work. You could have you could do that. So yeah, it's a very basic circuit. I wish I could I should draw it out, and I might at some point, but not right now. Just kind of interesting to see the difference between a modern solar light and a solar light from the 1980s. So if you stick around, well, not for the video, but stick around on my channel, I'll do another video of when I finally put a new battery and put this all back together to run it as a warm white LED. We'll plug this in now just so you can kind of get an idea. Turn that light off. It's my other meter keeps shutting off, the one that's monitoring the battery that I'm trying to resurrect. So let's see, that's plugged in. Let's turn it on. Cover that. Switches up. Why is that not coming on? There we go. I just wasn't getting it dark enough. Well, that's not bad. That's actually some nice light there. Oh, now we could play with the we can play with that potentiometer. Let's see what that potentiometer does. Let's see if it really does control the threshold. Let me get some electrical tape so that we can kind of fool it. Alright, let's see. So let me move this stuff. Put that there so you can still see it. I'll move this over. There we go. So that's coming on. I just barely want it to go off. Yep, that's what it is. See? On, off, on, off, on, off. So that must make it really sensitive. Let's see if my finger will be enough to block it. Not really. There we go. So we'll put it right at the edge, right when it comes on. There we go. So yeah, you get the idea. It's a neat setup. Once the battery's starting to draw some current now. That's good. I'm gonna take my meter out of the mix. Let's see. Yeah, it's starting to. I think it's starting to charge. You can see I have the leads from the power supply on it. I'm going to switch my meter back to volts so I don't blow up the fuse. And just for the heck of it, let's just see if it has any charge. Hey, look at that. Alright, it's only been running for a little bit, but oops. There you go. Now it's dropping off, but I think it might be enough to go onto the real battery charger. Hey, yep. Alright, the charging light came on the battery charger, so we're in good shape. As usual, I appreciate you watching. If you have any comments, put them down there. And don't forget to do the like and subscribe stuff. And keep an eye out for the next video. We will put a battery in this of some sort, whether it's the battery that I'm trying to charge back up, or a lithium, or some nickel metal hydrides maybe. I do have some of these. I kind of want to do it with that lead acid though. But we have our LED, and we will see how long it runs with a fully charged battery. So thank you for watching.